When an object accelerates, its motion is changing. Every second that goes by, when acceleration occurs, constant acceleration we're talking about, velocity goes up and down by predictable amounts. So we can predict the unpredictable. The acceleration graph is a function of time. It can be used to find the velocity of a moving object. When acceleration is constant, the velocity is changing by the same amount each second, and this can be shown by a straight horizontal graph. In order to find the change in velocity for a certain limit of time, we need to calculate the area under the curve. Now, when we're calculating the area under the curve, it means we're finding the product of the variables on the x and the y axis. So the area of this is the product of A and T. We know that acceleration is delta V per delta T, and that means delta V, let's just draw a line to separate what we just did. Delta V is acceleration times time. So the product of acceleration and time are the areas under the curve. Let's look at the area of one of these boxes. If it's one box, 1 delta 1a high and 2 delta t wide, the area of each of these boxes are 2 ATs, 2 meters per second. So if we had, let's just use our imagination. Let's say we had 1, 2, 3, 4, 5, 6, 7, 8, 9. Forgive my pitch. Let's say we have 9 of those boxes, and each of them have an area of 2. 9 2s are 18 meters per second squared worth of velocity change. The bigger the acceleration and the greater the time, the greater the delta V. So again, if we're interested in finding the delta V, or the change in velocity we experience, we can take the product of the acceleration, which is 4, times the time, which is 12, and 4 meters per second squared times 12 seconds gives us 48 meters per second of delta V. Let's just imagine. Let's say we did some more. Let's just say I'm seeing myself. Let's say again we accelerate for a greater period of time. Let's say, our first delta V for the first 12 seconds was 48 meters per second. Now just imagine we have to continue to accelerate for some reason. What are we doing to the total amount of area of under the curve as time goes on? The answer is it goes up. We have that red area plus that blue area. What is the area of that blue box, keeping in mind that each one is 1 high and 2 wide? 1 high and 2 wide gives an area of 2. So we have 2, 4, 6, 8, 10, 12, 14, 16 more area units. So we'd have 48 meters per second plus 16 meters per second worth. 8 and 6 is 14, 64 meters per second would be the new speed. The longer you accelerate, the greater the delta V you will experience.